Microservices, or microservice architecture, is a way of building software systems as a collection of small, independent services rather than one large, unified program. Each microservice handles one specific function in the system, like user login, payments, notifications, inventory, or search. These services communicate with each other through lightweight methods, often over the internet. The goal of microservices is to make software easier to scale, easier to maintain, and faster to develop, especially when many developers or teams are working on it. Before microservices became popular, most applications were built as monolithic systems, where all functions are combined into one big code base. All features run together, and updating one part often requires redeploying the entire system. This works well at first, but as the system grows, problems appear. One pain point is that it's hard to update, as changing one feature risks breaking others. It's also hard to scale, because the whole system must scale, even if only one part needs more resources. Slower development occurs as many teams working in the same code base create conflicts. Finally, system fragility means a small failure can crash the entire application. As businesses, data, and user bases grew, companies like Amazon, Netflix, and Uber needed a structure that could grow smoothly and independently. Microservices break the system into independent pieces, each responsible for one task. For example, instead of one big web app, you may have a user service that manages login and profiles, a payment service that processes transactions, a search service that finds products, an email service that sends notifications, and an inventory service that updates stock. Each microservice runs independently, can be updated without touching others, and uses its own code, database, and internal logic. It can even be built with any programming language and communicates with other services through APIs. This independence is the core advantage. Think of a restaurant kitchen. In a small cafe, one chef might cook meals, clean dishes, take orders, and handle payments. This is like a monolithic system, everything in one place. But in a large restaurant, there are specialized stations: a grill station, salad station, dessert station, beverage station, and cashier. Each station performs one job really well. If more salads are needed, you hire more salad staff, without changing anything in the dessert station. This is how microservices scale in software. Microservices are especially useful for large or fast-growing applications, providing scalability. Each service can scale independently based on demand. They also enable faster development, as teams can work in parallel without interfering with each other. Resilience is another advantage. If one service fails, the entire system may still keep working. Technology freedom means each service can use the best language or framework for its job. Easier updates allow deploying new features without restarting the whole system. This allows businesses to move quickly, adapt to market changes, and support millions of users smoothly. Microservices are common in large-scale, user-intensive platforms like Netflix. Netflix has thousands of microservices handling streaming, recommendations, subtitles, billing, and more. Amazon's entire online store is powered by microservices, one for product listings, one for checkout, and one for shipping. Uber uses microservices for driver matching, location mapping, payments, notifications, and surge pricing. Banking and fintech companies use microservices to modernize old systems and release new features faster. In short, if the app needs to grow fast and never go offline, microservices help. Even though each microservice runs separately, they still need to talk to each other. They do this with APIs, which act like phone calls between services. For example, the user service receives a login request. It asks the authentication service to verify credentials. The user service then responds to the app. Communication is structured, reliable, and often automated. While microservices bring many advantages, they're not perfect. They add complexity. One challenge is more architecture to manage, as many small services require good organization. Network communication between services must be reliable. Monitoring difficulty arises because failures are harder to track across multiple services. DevOps is required, as microservices benefit from containerization and automation. This means microservices work best when teams have strong engineering discipline. good monitoring tools, and automated deployment systems. Small beginner projects may still work better as monoliths.
Microservices are often used together with Docker, which packages each service into a container.
Kubernetes automatically manages and scales these containers. Cloud platforms like AWS, Azure, and GCP provide flexible hosting. These technologies help microservices run smoothly and scale globally. A microservice is a small, independent part of a larger system, each responsible for a single function. Instead of building one large application, microservices split the work into focused services that communicate with each other. This makes systems more scalable, resilient, and easier to develop, especially when many teams are involved or the system must grow quickly. In simple terms, microservices are like dividing a big job into many small expert roles, faster, more flexible, and easier to manage as the system grows.